Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again after months of spouting gibberish. The spaceship left the solar system in 2012 and is currently more than 15 billion miles from Earth.
In the frozen silence of interstellar space more than 14 billion miles from Earth, Voyager 1 just sent something back. Something that defies every expectation. It wasn't just data. It wasn't just static. What NASA received was impossible. A pattern buried in noise, a pulse of intelligence in the void. For over 4 decades, Voyager has traveled outward with no destination, no return. But now it may have found something, or something may have found it. What happens when a machine we built to explore the unknown crosses into something we were never meant to witness? This is not just science, it's revelation. The mission that refused to die. September 5th, 1977. A car-sized spacecraft carrying more computing power than the average 70s calculator launched from Cape Canaveral. Its name was Voyager 1, designed for just a 5-year mission to explore Jupiter and Saturn. No one expected it to still be sending data nearly half a century later. Back then, it was just one more probe among many. Today, it's humanity's farthest and oldest operating spacecraft. What made Voyager 1 last this long wasn't luck. It was engineering magic. It runs on radioisotope thermoelectric generators, RDGs, turning heat from plutonium into electricity. The thrusters that still keep it oriented today use hydrazine stored in tanks that haven't failed once in 47 years. Every wire, every component was built to survive the unimaginable. They weren't building for 5 years. They were building for forever. The design itself came from the Mariner and Pioneer programs, but Voyager was something else. Its body was wrapped in protective shielding to guard against cosmic radiation. It had redundant systems, so if one failed, another could take over. It was a spacecraft made to learn as it flew, and to endure what no machine had before. Interstellar space. JPL's team knew they had to build something different, something that could not only survive the unknown, but could keep talking to us through billions of miles. We didn't just build a probe, one engineer said. We built a voice in the dark. And so, against all odds, that voice still speaks. We are like butterflies who flutter for a day and think it is forever, Carl Sagan. And as that voice drifted through the darkness of space, what guided its journey wasn't just speed, it was timing. An astronomer's quiet discovery decades earlier had opened a once-in-a-lifetime window. A rare planetary alignment allowed Voyager to ride the gravitational fields of giant worlds like stepping stones. It was a slingshot effect that made Voyager's speed and escape possible. The next phase of its journey was all about using the universe's own force to keep moving, gravity's perfect timing. Back in the 1960s, a NASA engineer named Gary Flandreau made a discovery that would change space travel forever. He realized that once every 176 years, the outer planets, Jupiter, Saturn, Uranus, and Neptune, aligned just right. This alignment would let a spacecraft use their gravity to sling itself from one world to the next, picking up speed along the way. The timing was perfect for a mission in the late 1970s. Voyager 1 used Jupiter's gravity like a trampoline, gaining momentum as it curved around the giant planet. Then came Saturn, which gave it the final push. With no need for massive fuel tanks, Voyager 1 was hurled into deep space. This technique, called a gravity assist, allowed the spacecraft to reach escape velocity and leave the solar system entirely. The plan was brilliant. Voyager 1 would take the fast path to interstellar space, while Voyager 2 would take a slower route to explore Uranus and Neptune. By separating their paths, NASA expanded its reach. Voyager 1's trajectory was chosen for speed and distance, sending it toward the unknown faster than anything before it. Flandreau's discovery wasn't just about numbers on a chalkboard. It reshaped the way we explore the cosmos. It's like finding a highway through the stars, one mission planner said, and Voyager 1 was the first vehicle brave enough to drive it. Nature does not hurry, yet everything is accomplished. Lao Tzu, boosted by gravity and guided by brilliance, Voyager 1 now had front-row access to the most massive planets in our solar system. But it wasn't just passing by. It was taking pictures, capturing storms, and uncovering secrets. These encounters weren't just milestones. They were revelations, and what it found around Jupiter and Saturn would rewrite textbooks and stun scientists back on Earth. The next stop was visual proof of things we'd only imagined, revealing the giants. In March 1979, Voyager 1 flew past Jupiter and changed how we see our solar system forever. Its cameras captured swirling storms in motion, peeling back the mystery of the gas giant. The iconic Great Red Spot wasn't just a splotch. It was a storm bigger than Earth, churning for centuries. For the first time, humans saw this alien weather up close, alive and real. But the true shock came from Jupiter's moon. As Voyager zoomed past, it snapped images that revealed erupting volcanoes, active lava spraying into space. It was the first time we had seen volcanic activity beyond Earth. Scientists were stunned. "We thought moons were just dead rocks," one geologist admitted. Io shattered that belief in seconds. Then came Saturn. Voyager 1's flyby exposed its ring system in never-before-seen detail. Fine bands, braids, and divisions appear like brushstrokes in a cosmic painting. Voyager also found new moons, DB, Prometheus, and others, each with its own story. Mimas, with its Death Star-like crater, became an instant favorite among sci-fi fans. Voyager didn't just photograph planets. It mapped magnetic fields, sniffed out chemicals in atmospheres, and measured radiation belts. It made the invisible visible. The data it sent back opened our eyes to just how complex and bizarre these massive worlds truly are. Somewhere, something incredible is waiting to be known. Carl Sagan, with Jupiter and Saturn behind it. Voyager 1 had accomplished more than anyone could have dreamed. But this wasn't the end. It was only the edge of a much larger story. As it drifted farther into darkness, it crossed a boundary no spacecraft had ever crossed before. Beyond the reach of our sun's wind and radiation, Voyager 1 entered a new realm, interstellar space. What it found there would redefine what we thought was possible. Breaking the solar shell on August 25, 2012, Voyager 1 did something no human-made object had ever done. It left the solar system. More precisely, it crossed the heliopause, the invisible boundary where the sun's influence ends and interstellar space begins. Scientists knew this moment would come, but when it happened, the data told a stranger story than expected. The spacecraft wasn't just moving farther away, it was entering a completely different environment. As it crossed the threshold, Voyager 1's instruments recorded a drop in solar particles and a spike in galactic cosmic rays. These weren't particles from our sun. They came from stars light years away. We were finally outside the bubble, one NASA scientist said. The probe also picked up strange plasma waves, slow, undulating vibrations in space like echoes from distant cataclysms. The magnetic field out there was different too, stronger than predicted and oddly twisted. The spacecraft's magnetometer revealed that even in the emptiness between stars, space isn't silent. Instead, it's humming with energy. These findings forced scientists to rethink the shape and strength of the sun's protective bubble. Voyager showed that the edge of our solar system isn't smooth. It's ragged and complex. This wasn't just a new chapter in space exploration. It was the start of a new kind of science. Voyager was no longer studying planets. It was studying the galaxy itself. This was a whole new mission, said project scientist Ed Stone, and we were just getting started. The universe is not only stranger than we imagine, it is stranger than we can imagine. J.B.S. Haldane. But even as Voyager 1 charted the unknown, it began whispering back messages that left NASA puzzled. Something had changed in the data. Patterns emerged, unusual, eerie, and repeating. The team wasn't dealing with plasma or radiation anymore. They were facing a mystery. Was it a malfunction or something else? What followed would spark one of the strangest chapters in Voyager's journey, anomalies that seemed almost intentional. An astounding glitch in Toy 2. Voyager 1 began sending back data that didn't make sense. Instead of the usual telemetry, NASA's Deep Space Network received a repeating string of zeros and ones. Strange, rhythmic, and unlike anything the spacecraft had transmitted before. The format wasn't garbled. It was structured. Too structured to be noise. It lasted 15 minutes. Scientists called it a glitch, but many couldn't shake the feeling. It felt like a signal. The Allen Telescope Array, which monitors deep space radio frequencies, picked up the same pulse. Astronomers confirmed it wasn't interference. It wasn't from Earth, and it didn't match any known stellar event. We're seeing a consistent pattern, but with no explanation, one technician said. Tension grew at Mission Control. No one could say for sure what caused it. And even stranger, no alarms were triggered on the spacecraft itself. Naturally, the public began to speculate. Had Voyager detected an alien signal? Had it collided with something unknown? Online forums and media exploded with theories. NASA, usually quick to clarify glitches, remained unusually silent. Internally, the mood was tense. We didn't know what we were looking at, admitted to systems, engineer, and that was a problem. Eventually, the mystery deepened when no other spacecraft showed similar anomalies. Whatever happened, it was unique to Voyager 1. The mission was entering a realm where standard explanations were starting to feel inadequate. The data didn't lie, but also didn't explain itself. Not only is the universe stranger than we think, it is stranger than we can think. Werner Heisenberg. The space agency had a choice: dig deeper or dismiss the noise as technical error. And what they found next wasn't supernatural, but it was still unsettling. The answer, though human-made, raised new concerns about how fragile our link to Voyager really was. The solution seemed simple, but the implications weren't, because in space, even the smallest error can reveal something far larger than expected. Back to basics. After months of analysis, engineers finally traced the bizarre telemetry to an unexpected source: the Attitude Articulation and Control System, or ACS. This is the part of the spacecraft responsible for keeping Voyager's antenna pointed toward Earth. Somewhere along the way, the ACS had started sending its telemetry data to the wrong computer. It wasn't a malfunction, it was a misroute. The spacecraft wasn't in danger. It was just speaking the wrong language to the wrong part of itself. Once this was discovered, NASA sent new commands to reroute the data correctly. And just like that, the signal cleaned up, but this fix raised more questions than answers. How did the ACS decide to reroute itself without instruction? It wasn't designed to do that on its own. What troubled engineers most wasn't that the error happened, but that no-fault detection system flagged it. Voyager is equipped with self-check protocols, especially for mission-critical systems like orientation and communication. This error slipped past all of them. It didn't trip alarms. It didn't degrade performance. It simply changed. This led some at NASA to quietly wonder, was it a fluke, or was something triggering the spacecraft to protect itself in ways we didn't understand? Voyager software was written in the 70s. Could it be evolving? Could deep space conditions cause it to behave differently? We fixed it, said the project lead, but we don't fully understand how it broke. There are more things in heaven and earth than are dreamt of in our philosophy. William Shakespeare. With the signal restored, the Voyager team breathed a sigh of relief. But it was a quiet one, because in that strange malfunction lay a deeper truth. The machine had gone beyond what we thought it could do, and as its power faded, each message became more urgent. Voyager was on borrowed time, but it was still talking. And what it said next would be among the last whispers of a dying giant. The final countdown. Voyager 1 is on borrowed time. Fueled by decaying plutonium-238, its power drops by about 4 watts every year. With less juice, NASA has shut down non-essential instruments. Only core sensors like the magnetometer, cosmic ray detector, and plasma wave antenna are still running. Each surviving system now beams back the last whispers of the heliopause and the edges of the Oort cloud. Hydrazine for attitude control also dwindles, and once it's gone, Voyager may no longer aim its antenna at Earth. Yet despite these limitations, NASA aims to squeeze out every last bite of data, searching for tiny magnetic wiggles, subtle cosmic ray fluctuations, and maybe hints of the solar system's distant frontier. Every faint signal now has a story to tell. In a way, Voyager's fading power makes each signal precious. Each packet becomes a snapshot of the outermost reaches of human exploration. Data humanity might not see again for centuries. We're racing against a timer built half a century ago, a team member noted. As scientists chart its final path, they wonder, can the probe reveal just enough before it falls silent? But while the countdown continues, another question emerges. What lies ahead for Voyager when its instruments finally shut down? Will it drift as an empty shell, a silent icon of human ambition, or still fulfill its final mission, carry perpetually toward Proxima Centauri b? As power fades to nothing, a new chapter begins, characterized less by signals and more by enduring legacy. With each passing year, Voyager's signals fade, but its mission grows more profound. The questions it still seeks to answer may redefine our understanding of the farthest reaches of our cosmic neighborhood, but there's still a larger cosmic question hanging. Could the silent explorer eventually wander into the realm of another star? The possibility ignites our imagination and leads us to the final leg of its journey, beyond utility and into myth, the ghost ship of Proxima Centauri b. If Voyager 1 keeps coasting through interstellar space, projections suggest that in around 16,000 years, it could pass within a few light years of Proxima Centauri b, the closest known exoplanet. Imagine the silent probe still drifting, perhaps even recognizable by some distant, unexplored civilization. Its golden record is humanity's greeting in a bottle cast into an endless cosmic ocean. This distant future is no sci-fi daydream. It's a reminder how vast time and space truly are. Voyager will become a ghost, moving silently, its maps of cosmic rays, magnetic fields, and interstellar dust frozen in time. It will carry the story of Earth far beyond what we can see, beyond what we can imagine. The golden record, a time capsule of Earth's music, voices, images, and greetings in 55 languages, might outlast everything else aboard. To the distant future, we send a signal of who we are. Carl Sagan wrote, "It reminds us our curiosity, creativity, and desire for connection define us as a species." In time, Voyager will drift unmanned, carrying its stories and maybe even silent observers through unknown space. But even without transmission, its message endures that humanity once reached out, built a messenger for stars, and dared to ask cosmic questions far bigger than itself. Voyager's journey becomes legend, an interstellar ghost ship carrying our collective identity across millennia. Yet even now, in our own time, the story continues. From misfires and system glitches to engineering triumphs, the probe has taught us about persistence, curiosity, and the unknown. And now, in its search for new frontiers, we must ask ourselves one final question. What lessons do we learn, and how do they shape our next generation of explorers? The impossible proven and lessons learned from a 5-year mission to study the gas giants, Voyager 1 turned into a spacecraft that defied every prediction, surviving power loss, cosmic radiation, and the silent void. It transformed from an instrument into a legend, proving humanity's capacity for bold design and long-term thinking. It stands as a symbol of hope and aspiration amid the vastness of space. Voyager 1 taught us that engineering matters. Redundancy isn't just insurance. It's a lifeline. Shielding against radiation isn't optional. It's essential. And planning against obsolescence, not just ground-side updates, but durability in deep space, is crucial. We saw how early decisions shaped the mission's longevity. This mission also highlighted the fragility of distant communication. Even a tiny misrouted data stream, in 2022, became a cosmic mystery. It reminded us that as we push into deeper space, our designs must anticipate unexpected behavior, and importantly, that we shouldn't silo teams or ignore soft failures. Voyager ends its journey as a question more than an answer. We asked, can we reach the stars? It showed us we can. But it also asked, will we think long-term and plan with care? Each phase, from gravity assist to last signals, serves as a blueprint for future interstellar missions. Voyager's legacy isn't just where it went, but how we go. Voyager 1's Odyssey isn't just history. It's a guidebook. It reminds us that exploration is messy, unpredictable, empowered by curiosity and ingenuity. The next leap, from interstellar missions to true starflight, rests on lessons learned here. We must keep asking bold questions, designed for endurance, and expect the unexpected. And as we prepare for the next generation of cosmic voyagers, we must remember, the real frontier isn't just beyond the sun. It's how we choose to reach it. In the frozen silence of interstellar space, more than 14 billion miles from Earth, Voyager 1 just sent something back. something that defies every expectation. It wasn't just data. It wasn't just static. What NASA received was impossible. A pattern buried in noise, a pulse of intelligence in the void. For over 4 decades, Voyager has traveled outward with no destination, no return. But now it may have found something, or something may have found it. What happens when the machine we built to explore the unknown crosses into something we were never meant to witness? This is not just science. It's revelation.